Hi there, this is video 1.4. We are dealing with counterexamples part 1. It refers to section 1.2 in your textbook. Basically, so far we've learned about conjectures and inductive reasoning. And they're kind of almost the same thing, but a little bit different. So inductive reasoning is the process of seeing some data and drawing a conclusion from it. Okay, and that conclusion is called a conjecture. So the process is inductive reasoning. The answer that you get or that you draw from the data is your conjecture. The problem is you never really know for sure if you've looked at all the data. There might be an exception somewhere out there. And frankly, that's what a counterexample is. Okay, so you might find conjectures that are valid at first, but are not true later. A conjecture may be revised based on, counterexample. All right, so if you take a look at these lines at first glance, which is shorter? Is it this one? Like the horizontal part. Is this horizontal part shorter or is that one? Well, here's the crazy thing. I can measure them, but you know what? If I just do that, you can actually see they're exactly the same length. Okay. This one, I'm not even going to try and explain because I don't know if on this tuning fork there are 2 prongs or there are 3 prongs. There's a lot of famous optical illusions out there. I just stole a couple easy ones. Okay. The Earth is the center of the universe. Like, think about it. Like, way back in the day, the sun rose in the east and it set in the west, and every day. So it makes complete sense that the sun is orbiting around the Earth. We know that's not right, but it made sense in the day. Okay. I could say that all my students have brown eyes. That's a valid conjecture. Every student I've met so far has brown eyes. Until I meet one that doesn't. That just proves my conjecture. Okay. All animals that live in the water are fish. Can you name me a counterexample right now? Yeah, I'm thinking dolphin, lobster, seaweed. Oh, seaweed doesn't count, it's not an animal. All right, but there's always often with a conjecture, there's a counterexample, which kind of like wrecks it. All right, so another one, if you live in Regina, the only way to get to Vancouver is by traveling west. Well, no. How else could you travel? I could travel east. It would take me an awful long time. It would be probably a really cool trip to go to Newfoundland and then to Paris and across to Asia and then get to Vancouver. But you could get there. Theoretically, you could get there going the other direction. All right, so a more formal definition. An example that invalidates a conjecture. Okay, translation proves that conjecture wrong. I guess I could have just said disproves a conjecture, but I didn't think of that until after. All right, so an example, the sum of a multiple of 3 and a multiple of 6 must be odd. So if we do multiples of 3, 3, 6, 9, 12, 15, 18. It's probably enough. Now we need multiples of 6, right? This is 3 times 1, 3 times 2, 3 times 3, 3 times 3. You get it. So 6, 12, 18, 24, 36, 42. So we need to add. So sum, remember, sum is add. And so can I pick 2 that add together? It says they're supposed to be odd, so 3 and 6 is odd. But you know what? If we just go there, 6, which is a multiple of 3, and 12, which is a multiple of 6, when you add them together, 6 plus 12 is 18, not odd. All right, so that's all there is to disproving it. So that means that this conjecture is disproved, it's incorrect. I don't really know how we could fix that. Are they saying it's either odd or even, which means that any number will do. All right, now it says the difference between a multiple of 11 and a multiple of 7 is either even or divisible by 3. Okay, so 11, 22, 33, 44, 55. Okay, so there's my list of multiples. 11, multiples of 7, 14, 21, 28, don't touch me, 35, and let's go 42. All right, so difference, if you remember, means subtraction. And so we start subtracting, so 11 minus 7 is 4. 22 minus 14, I don't know. 22 minus 14 is 8. Okay, we're good there. 33 minus 21 is 12. 44 minus 28 is 16. Okay, well, this isn't working very well. Not even getting multiples of 3. Well, it looks like that pattern isn't working, so let's try 14 minus 11. Oh, well, it's going to give me 3. So basically, I'm taking a number either from top or bottom and subtracting and hoping I get something that isn't even and isn't divisible by 3. 22 minus 7. Oops, can't see. That's 15. Hmm. 55 minus 7, that's going to give me 48. That's not going to work. 55 minus 28. Well, this was in the list of things you should be able to find a counterexample to. So it looks like I'm going to continue this on my own, looking for a counterexample, possibly trying to do some weird math to see if one even exists. And in the notes to the video and on the answer key, they'll have something written where I have the example. Oh, in case you're wondering why there was a curling rock, I was going to give you a lovely example of a personal counterexample. So my dad is a curler. He's pretty good. Okay. My mom curled, my sister curled. My sister was gone to national. So, you know, it was a good family of curlers. So one night I was out with my sister and her curling team, and their skip, who's the head of the curling team, looks at me. She goes, like, she said, you curl. And I said, well, no, I don't. And she goes, you have to curl. I know your dad. So she made this beautiful conjecture about her entire family because everybody else curled. So I must curl too. And I was the counterexample. I am a bit of a black sheep in our family because I'm the only one that doesn't curl. So be the counterexample. It's a good thing for you. Have a great day.